My name is Linda. I'm a children's book author, I'm a very mediocre programmer, I'm a business school dropout, I'm many things, and this is the theme of the talk today. Computers are binary. They can be one thing or the other, 0 or 1, on or off, but we humans contain multitudes. We can be many things at the same time, and that's, I think, the promise that all of you are bringing to the technology industry today. As mentioned, I co-founded Rails Girls, which spread into many different places, and through that I realized that there is not really a place for the way I see the world of technology in the world right now, that I actually need to start projecting and building the way I experience software in order to really see a future where I could fit in. And this is kind of the ethos I started with. If programming is the new lingua franca, if our kids are going to be learning English, Chinese and JavaScript in schools as their first foreign languages, instead of grammar classes, we ought to be teaching them poetry lessons. And what I mean with that is, often when we talk about technology, we talk about the grammar, we talk about how to conjugate verbs and how to practice the punctuation rules, we talk about what an if-else statement is or how a loop works, and we forget about poetry. And I don't know about you, but at least the way I learned English was by reading and by writing and by flirting with boys online and stuff like that. And that's what I wanted to see in the world of software. So when I was studying coding, I would start to make these little doodles at the margins of my computer science book. And because the language I was practicing at the time was Ruby, I imagined a little fierce 6-year-old girl with a ponytail, and every time I would run into something that I quite didn't understand, like what is object-oriented programming or what is garbage collection in mobile development, I would do a little doodle and explain it to myself. And it's interesting that we live in this world where there's so many opportunities of learning technology, everything from these puzzle-based activities that Coded.org offers to the sort of open-ended playgrounds that Scratch gives out. But my big question was, where do stories fit into this equation? Because that's the way humankind has always learned. We learn about ourselves, about each other, and about the world around us through stories. And for some reason, no one was really telling stories about the world of software. So these little doodles I would do, they started as jokes. I would imagine, what if Apple was a character? It would be the snow leopard who never wants to play with the other kids because they are too messy. It only likes well-designed and beautiful things. And if Linux was a character, it would be the really book-smart penguin that is ruthlessly efficient but somewhat hard to understand. And I go to my mom and tell her, Mom, I have an amazing idea. This is what I want to do after dropping out of university. And she goes, that sounds like a horrible idea. That sounds like a Soviet propaganda book from the 70s. Why on earth should kids understand how big technology companies think? Well, the reason is because governments can't reach billions of people anymore. Religions barely reach billions of people anymore, but big technology companies, they reach billions of people on a daily basis, and it matters what kind of people, values, and structures are inside of those companies. So this was the idea, and it started as a tiny idea for myself, as almost a joke, a side joke, but it bloomed into something way bigger with the crazy Kickstarter project that represented almost 20% of the annual book exports of the entire country of Finland the year I did it, and I had never done a book at this point in my life. And in the past 4 years, the book has been translated into 25 different languages, and it's actually grown from a programming book into a series of books that explains a more and more technical world. Because here's the thing. I think what I'm doing right now is not teaching kids coding. I'm preparing them for a world where more and more of the problems around us are computer problems. But the biggest, the hairiest, and the most difficult problems in the world are not going to be solved with the current engineers alone. We need a radically more diverse group of people using computers and technology to solve these problems in the world. And with that in mind, today I wanted to show you 3 big ideas of computer science, because as a really famous computer science researcher, Dijkstra, says, he says that computer science has as much to do with computers as astronomy has to do with telescopes. So you can really teach these thinking structures, these thinking skills, even prior to doing one thing with a screen. And in practice, it might look like this. This here is Ruby. She's 6 years old, very bossy, completely fearless. And when Ruby's dad tells Ruby, "Hey Ruby, we're running late from school, dress up really quickly." She does dress up, but she leaves her pajamas on because dad didn't specifically first tell her to take the pajamas off. And if Ruby is told that, "Oh Ruby, your room is a mess, clean up all the toys," Ruby cleans the toys, but she leaves the pens and papers on the floor because, come on, Dad, pens and papers are not really toys. And there's a chance I'm raising the most obnoxious generation of kids ever. I apologize for that already in advance. But they also learn something very profound about how to speak to a computer. Namely, you need to give very exact commands. Instructions need to happen in the right order. You need to be careful when you name things. You need to take into account all kinds of wacky situations that the computer might run into. And then finally, and most importantly, even the biggest problems in the world, they are just tiny problems stuck together. So we're going to practice this through the A, B, and C of programming. And the first is A for algorithm. And we're going to do a really quick exercise here, 1 minute, where the other one of you is the programmer and the other one of you is the computer. And the programmer's role is to break down the act of washing or brushing your teeth. Which one is it in English? Well, brushing your teeth into sequences. So move your hand towards the toothbrush. Computer doesn't know what a toothbrush is. Redefine. Stop moving your hand towards the toothbrush, and so on and so on. And I'll give you 60 seconds, and I want to hear a lot of computers going here. So the other one is the computer, the other one is the programmers. The task is to teach the computer to brush their teeth. Go! Okay, this is a short talk, so this was a short algorithm. I heard a lot of laughter. That's a really good sign. Programming is a really fun activity. It went well, right? I think so. I heard a lot of good sounds. How many made a mistake? Raise of hands. Amazing, really awesome. How many discussed the problem together or asked for help from the programmer or someone else? Oh, that's okay. I would wish to see more hands up in there, because these two things are so foundational to computer science that we have even special names for them. The act of working together is called pair programming, the idea of two pairs of eyes seeing problems better than one pair of eyes. Computer science is thoroughly collaborative. We work together. And the act of making a mistake, of not figuring out the right thing at the get-go, and going back and solving that problem, is called debugging. And computer science is full of these thinking skills, these persistency, creativity, and collaboration-related skills that are equally important to teach for a good computer scientist in the future. So it turns out that an algorithm is what you all did just now. You did a step-by-step sequence to solving a problem. If you've ever done any recipes, you've followed an algorithm, because a cupcake recipe, you can make one cupcake, but you can also make 100,000 cupcakes. You can make cupcakes with banana or blueberries in them. And some of you might now be thinking, that's all fine and nice, but this is not what computers do. Computers don't teach each other to brush their teeth or to make cupcakes. Well, a computer is a special kind of device because it does sorting, and it does searching, and it does filtering. So if I were to ask all of you to sort these 5 numbers into order of magnitude, it would probably take you 4 or 5 seconds. If I were to ask you to do this one, it would take you a little bit longer, or even this one, again, a longer time. For a computer, all of this is equally easy. So a computer is really quick at going through sequences of steps over and over again. And the way a computer does this is by having been given a really good definition. So for instance, the way a computer would sort these 5 numbers, it would start from the beginning, it would compare 1 and 56. It would say 56 is bigger than 1, let's move on. 56 is bigger than 4, let's swap. It would compare 56 and 70, and then it would go to 70 and 20. and swap them again. And then it would go all the way back to the beginning and do this over and over and again. And this is called a bubble sort algorithm, an algorithm that someone wrote down to instruct a computer how to sort long series of numbers in a somewhat efficient way. And the way we see algorithms right now is through search results. Every search result you see is an algorithm that decides what kind of search results get shown to you, what kind of ads get shown to you. If you go to a social networking site, we've all been told this recently, the kinds of ads you see, the kinds of updates you see, those are all defined by an algorithm. And if you go to YouTube, the kinds of videos you see and you get suggested by, again, an algorithm in work. But computer science goes deeper than this. It's much more fascinating. And there's so many topics that we could talk to you today, but they often get discussed at a very abstract level. And anyone here who's studied pedagogy knows that you can't really make anyone enchanted about a discipline by only offering them a pre-packaged vocabulary of content. True learning is grounded in action, and it requires us as computer scientists to ask very different kinds of questions than the ones we feel familiar asking. So we like asking questions like, define to me what a loop is. Rather, we should be asking questions like, how does a loop feel like? So a loop is a construction in computer science that says that a computer is really quick and really fast at repeating sequences of instructions. And in Ruby's world, we practice this by having a dance party. Ruby's favorite dance movement is clap, clap, stomp, stomp, clap, clap, and jump. And we practice a for loop, which is one type of a loop where the kids get to repeat this dance sequence 3 times. We practice a while loop where they repeat this dance sequence while a condition is true. So for instance, while I'm standing on one leg. And then finally, as homework, they get the until loop where they repeat this sequence of dance movements until a condition is met. So for instance, until the mom gets really, really frustrated with them. And in this way, I'm hoping the kids get this very physical sensation of what computer science feels like. Then they might go into something like Scratch or real programming languages. And very, very importantly, we ought to give people the context of why on earth are they learning this thing. Because every time you log into a website, odds are there's a for loop that asks you to repeat your password 3 times before blocking the account. Or if you make a game, there's definitely a loop that says, keep moving the hero until it hits the enemy. So understanding computer science and thus the world around us through these abstract components turns out to be one of the most fascinating skills you can learn. And there's even a word for it. It's called computational thinking. It's the idea that we humans need to structure problems in a way that a computer can understand them. And they include concepts like decomposition, taking apart a big problem into smaller pieces, understanding algorithms or automation, but also these very human skills like creativity, like persistency, like collaboration. So the next step in this ABC of technology is boolean logic. Because we've kind of danced around the idea of a computer. We've talked about programming, but what really is the computer? I'm somewhat jealous for the people here who grew up in the 70s because you had this very tangible relationship with computers. You could actually take a computer apart and see what's inside of it. You could touch a transistor. For our generation, you can jam 300 million transistors at the pinpoint of a pen, and there's no way of explaining how these sealed magical devices work anymore. And sometimes I wish I could shrink myself to the size of a silicone chip and go inside of a computer to learn really how it works from the inside. Unfortunately, that's not possible with modern day physics, but that's possible if you're a children's book author. So that's exactly what I did with little Ruby, plunging her into this adventure. So Ruby goes into Dad's office, she types her password in, the computer doesn't work. And all of a sudden the white mouse wakes up next to Ruby and says, "Oh Ruby, I've lost touch with the cursor. Can you help me find the cursor?" And Ruby says, "Of course, I'm the best computer debugger I know of." And they make themselves very, very small. And they fall deep, deep inside of the computer to the layer of the electricity, where there's billions of tiny switches that only know how to go on and off, on and off. And they are not much use in finding the hidden cursor because they are so complex and it takes a lot of them even to convey the simplest thing. So up they go until they meet the logic gates, these mathematical devices that take the bits and make them into a little bit more complicated operations, but still too hard to actually have a discussion with. So they meet the hardware layer of the computer, the bossy CPU that gives instructions to everyone else but is really forgetful, so it needs the help from the RAM and the ROM and the hard drive. They go visit the operating system, and I'm not going to spoil how the story ends, but they do actually find the missing cursor. But I think even more importantly, that they get this very tangible idea of a computer as an abstraction machine. Because today computers are digital, but tomorrow they might be theoretical, they might be biological. And giving kids a robust sense of what a computer is one of the important things we can teach them. Because today, computers are everywhere around us. I show kids between 6 and 9 this photo of a car, a grocery store, a dog, and a toilet, and all of them are computers. A dog might have a microchip inside of it. A car has a navigation system. Grocery stores have hundreds of computers inside of them, and don't do this with small kids, but in toilets, in Japan, toilets are computers, and there's even hackers who hack them, and this is like mic drop moment with the kids and nothing else gets discussed after this. So there's hundreds of computers in every single home, and this is the last generation of kids that will remember the computer defined by the screen, defined by the keyboard and the peripherals. When they grow up, their teddy bears will be computers and their toothbrushes will be computers. And one of my favorite low-tech activities to test this out is this one. I collect everyday objects for the kids, like a tuna can, or a book, or a lipstick, or a pair of keys, and I give them a little tiny sticker with an on-off button on it. And I tell the kids that for this afternoon you have this magical ability to make anything in this room into a computer by placing this sticker on the thing. And the little girl, she comes to me. She's chosen a bicycle lamp. She's put the little sticker on the bicycle lamp and she goes, "Linda, if this bicycle lamp were a computer, I could go on a biking trip with my father. We could sleep in a tent, and this bicycle lamp, it could also be a movie projector." And that's the moment I'm looking for. Not the moment when the kid understands the difference between arrays and hashes in Ruby programming language, or writes the perfect if-else statement in JavaScript. The moment when they understand three really profound things. First of them is the world is not ready yet. There's so much we haven't discovered or invented. The bicycle lamp movie projector, maybe not the most important one out there, but that still doesn't exist. Second thing, technology is a wonderful way to make the world a little bit more ready because it scales and it creates wealth around it. And third and most important thing she learned was that she herself can be a part of the change. She had the self-agency, self-belief, and self-efficacy to believe that she could be the inventor of the future bicycle lamp movie projector. And I think that's what I'm trying to look for in kids. So instead of making them programmers, giving them a very robust idea of a notional machine, of what a human is good at and what a machine is good at, and what kind of jobs will computers be good at in the future, and what kind of computers we humans will excel at. Because this all leads to the third and the final computer science topic of today. It's for creativity and the future. This generation of kids, in addition to not being defined, remember the computer defined by their screen, is going to be the generation that also has their first experience of AI before they even speak. They grow up with Alexa and Siri. They will have a hard time separating what is real and alive and what is artificial. And this is where I see the biggest distinction between generations. There is this adult generation that when we say the word AI thinks of Skynet and Terminator and thinks of these medieval monsters coming from underneath, uninvited guests basically. And then there's this generation that has never used a paper map, that has always been able to find their way in the world by the GPS, And even further from that, who's always been able to use the data that machine learning provides in order to avoid the congested streets, who always has had this ability to navigate the world in real time with the help of the AI. And I, for one, would want to see a more optimistic, a more curious, a more creative group of people embrace machine learning and AI and understand that it's nothing scary. That while computers are magical, they are not made of magic. They are made of logic, and that's a big distinction. And when we think about machine learning, the idea that we're starting to give computers these abilities that humans traditionally have had, the ability to reason, the ability to create, the ability to perceive, these are very specific technical things we're teaching them. It doesn't mean that we're 1 ounce closer to the artificial general intelligence. So for all the parents in the room, I'm going to do a really quick recap of what machine learning looks like, so you can be on the side of your child and be like, yeah, this is cool. So machine learning, and where the biggest advances sort of in the past years have happened, is basically this. In the past, if we asked a computer to define if this picture is a cat, it would require us to write a lot of code. It would require us to write an algorithm that checks if the cat has ears, or if the cat has a tail, or if the cat comes in these 100 colors, odds are that it's a cat. So we would give the computer the rules and the data, and the computer would come up with answers. What's happening with machine learning is that we're doing the opposite. We're giving the machine billions of examples of cats. We're allowing the machine to build the model around those cats and figure out its own rules of what a cat ought to look like. It might not look like nothing like the stuff that we humans use to recognize cats. And then it gives the answer that yes, this is or this isn't a cat. And the exciting thing here that people also fear is the idea that we don't know exactly how a machine comes up with its predictions. This is the stuff, the fear-mongering stuff you see in the tabloids, that the researchers don't know how the computer does this thing. Well, the researchers don't know, but we don't know how humans recognize cats. We don't know how a human child from 5 cats learns the concept of a cat. And this is the equal thing. We don't know exactly what's happening, but we still understand the process, and this is not general intelligence. The stuff that is really fascinating here is the data, because again, all of the advances have happened in this type of machine learning, where you give the computer a lot of information, the computer comes up with the rules and gives the answers. But what about that data? Because it comes from us humans, we generate that data. If we give a computer examples of cats and by accident all of the cats are grey, the computer will come up with the idea that all cats are grey, and it will not be able to say that a pink cat is a cat or a blue cat is a cat. But it's even more scary when you give a computer a bias that exists in our world. If we give computers examples that all nurses are women, a computer will never be able to understand that a male can be a nurse, and you can think of many of these kinds of examples. And this, I think, is the area of computer science where we especially need all of you to bring out those diversities, bring out the experiences, and bring out the blocked areas or the black holes that the computer scientists themselves don't recognize, the biases. I think the next big thing is not going to be big data, it's going to be the small and weird and funny data. It's not going to come from Silicon Valley, it's going to come from all of you who start to embrace and allow their own creativity to come to technology. And when I think about the future, I can't help but think about this story from Little Prince. You know the story where Antoine Saint-Exupéry, he draws a picture of a boa that has eaten an elephant, and the adults only see a hat, but the kids obviously know that it's a boa that has eaten an elephant. And Antoine says that these are not the people he wants to work with, then he ends up only talking about the boring adult optimization, domination stuff. And I couldn't help but wonder, what is sort of the mutual thing we humans will do with our machines? And will machines be anything like the starry-eyed kids in the world? So I gave this image to Microsoft image recognition AI, and it says this. I'm not completely sure, but I think it's a guitar. And I love this because I think this shows us a path into the future where man and machine work together in a creative manner, sparring one another, the human asking the question and the machine giving some wacky and weird and wonderful answers. Here's the thing. A few months ago, I read this article in The Guardian that stated that British kids have more language to express Pokemon species than natural world around them. So they recognized Bulbasaur better than the badger, they recognized Weasel better than the Weedle better than the Weasel. And the writer was really worried about what happens in a world where we don't have language to express what is happening around us. And I would argue that that is true. We need the 7 kinds of words to describe the snow we get in Finland, and we need to understand our world, but it's also happening in the tech realm. Because how many of us can actually explain what a DDoS attack is, or how the blockchain works, or what a bubble sort algorithm is? Well, all of you can now do that. And for instance, the internet, is it the hardware layer of the world? Is it the servers and the fiber optic cables that go from the bottom of the sea all the way to space? Or is it the protocols that govern how data travels around the world 9 times in a second? Or is it the cat videos we watch and entertain ourselves with? It's all of those things, and I think this is the challenge with technology. You're never teaching one thing. You're teaching the hardware, the software, and the cultural impact layer. But at the core of all of this, it's us humans. Technology is built of us humans. It's even in the word technology. It's the tools to solve a problem, but not only the tools, also the skills and competencies we humans bring into the problem-solving equation. The first computers in the world were humans who were good at calculating long series of numbers. The last computers in the world will be humans again. It's not a binary world of ones and zeros. We contain multitudes, we can be many things at the same time. And the most reassuring thing is that the kids know this. So I asked a bunch of little kids in Helsinki, 9-year-olds, to define to me what is technology, who uses technology, and what is it used for. And my favorite answer comes from a 9-year-old girl who says, technology is electricity that loves. I'm just gonna pause there for a second because this is the most poetic explanation of technology you will ever hear. Technology is electricity that loves. It is used to play. I used to have a conversation with my mom. We used a WhatsApp application, and then finally, and most importantly, people uses technology. Thank you very much.